Hello, everyone. Welcome to my talk on building scalable and reliable data platforms. Before we directly jump into this topic, let me start with simple questions. Are you confident that your data platforms can work the same way even though your data volume is increased? Are you confident that your reports, what you are looking at, is it accurate? Because building the scalable platforms is not just working with the large amount of the data. It's about even at the scale, you are not losing any of your trust on that particular data. You should not lose the data correctness as well. With that in mind, I'm here today to share my knowledge about how to build these particular platforms. With this, let me introduce about myself. I'm Sravanthi Kondoju. I have over 17 years of IT experience. I am currently working with Target as a data platform lead. In this session, we are going to discuss about first, let's understand what is data platforms. And then we'll understand about the important things related to the platforms, which are scalability, reliability, and then availability. Then we see why the scalable and reliable platforms are needed and what are the key foundations of these platforms. And then we'll also discuss about step-by-step approach of how to build these scalable platforms. And also we see how we can design this reliability in the data platforms. And finally, we'll end with some of the anti-patterns we'll discuss and then with the Q&A. This is the data platform architecture. If you take any of your pipelines which are running your data platforms, this always has ingestion layer and then processing layer and then final curation layer, reporting layer, what we call it as. So in the leftmost side, you can see the data sources. Those are nothing but you should identify where your data is coming from, whether it is coming from the flat files, whether it is coming from any of the API systems, and then any real-time streaming data comes from the clickstream related sources or traditional RDBMS systems as well. There are n number of the data sources where you bring your data from. And once you identify this data, you need to understand whether you want that data to be in the batch. That means whether you want to load this on a daily basis or hourly basis, or you want it in a streaming manner. That means the streaming manner, I wanted to get this data as soon as any of the event comes in, and I wanted to process that event, real-time streaming data and near real-time as well. So once you identify these sources and ingestion patterns, you can identify where you want to store your data. You want to store it into your data lake, or you want to store it into your data warehouse, or you want S3 storage buckets or GCS buckets, ADLS or Hadoop HDFS, Hadoop distributed file system. These are the different ways where you can store your data. So once you have that data, to take any of the business decision, you must need to process your data. That is where we have these processing layer in place. Whatever the cleansings, transformations, quality checks, validation checks, all these things you will be doing at the processing layer. That is where we have our Spark jobs. For example, the distributed processing will be done through the Spark. Or you can write your the other ETL tools as well. But as we are discussing about the ELT pipelines, the primary things you use right now with the Spark, or you can also initially use to do with the MapReduce. There are n number of ways you can process your data, and finally that data is available to the consumption layer. That is where your BI reporting teams, they get connected to your consumption layer. So for example, if you are under GCP, we have BigQuery. That can be a consumption layer. So your Looker or some Tableau or any other reporting tools get connected to BigQuery. Or if it is a Hadoop systems, you can connect to the Hive tables as well. There are different layers where you can, different tools you can store your data into the consumption. So the primarily, if you take any of these data platform, it must need to pass your data through these stages. Identify your sources first and then ingest your data, then store that data, and then you have to process it. And then finally, this is available for the consumption purpose. That is where if you are talking about the medallion architecture, the bronze, silver, gold, these are the three primary layers which you can tag this under the ingestion, processing, and finally the reporting consumption layer. Now we know how the data platforms looks like, and now we see that what are the primary things in the data platforms we should understand, because the amount of the data which we are handling in those data platforms is quite huge. So we need to think about the scalability, reliability, and availability. These are the important things which we need to consider. What is the difference between these? So if you take a look at the scalability, that is, for example, the first question I asked is like, when your data is increasing, the volume is increasing, your current platforms can handle it or not? That was the first question I asked. So that is directly pointing to the scalability perspective. The first thing you should think about is your platforms able to handle when my data volume is increased, or the number of pipelines were increased, or the number of queries what is being submitted is also increased, especially with the data growth or more number of the workloads which have been running. Then we also need to think about reliability. Reliability is nothing but, is your data correct? The data correctness, or am I getting a lot of duplicate data, or am I getting a loss of data? And the data correctness is a primary thing, especially even though when you're dealing with a small amount of the data, larger amount of the data, you must need to do these data correctness checks as well. And the availability is nothing but, especially if any of the service is not, for example, there is no high availability. That means the single point of the system is there. If that goes down, can you still run the same jobs as it is? It has to be remain accessible as well, the data, whatever we are talking about. Even after the node fails, even after that the major master component fails. So that is where high availability comes into the picture. The active actives or active passives, those kind of the things which you will be setting it up for availability. And when it comes to the reliability, we will discuss in the next slides more details about how you can do these checkpointing, how you can replay. Along with that, we'll also discuss about how you can set it up your scalable systems and reliable systems as well. With this in mind, we'll see why scalable and reliable platforms are needed. The first and foremost important factor is the amount of the data what we are handling is explosive data growth currently. Especially when you look at the past decade, the amount of the data right now is increased drastically. Even these data is being used for the multiple use cases, the AI/ML use cases, or there are both batch and streaming use cases. To handle all those things, your platforms are also should be able to scalable. It should able to perform any of these operations without fail. And in addition to that, to support the business agility and innovation, that is where these AI use cases or any of the real-time streaming use cases also comes in, those got increased drastically. So if you want to maintain your stable performance, then you must need to have a scalable systems. And when it comes to the reliable, why we need reliability? Because we should able to see that whatever the data we have, it should be accurate and it should be consistent as well, because all the decisions are being made by the data what you are currently handling. And also this reliability, you should ensure that no data loss should be there. And along with that, you should even enable your systems to do a replay of this particular data or retrial of this particular data in case of an API or in case of a batch or a streaming. By looking at these large amount of the volume of the data, along with that, the use cases what we are handling with the analytics and decision making, which requires a lot of accuracy and also the consistency of the data and no duplicates and correctness of the data is very important. With these, what are the key foundations of your scalable and reliable data platforms? The first and important factor is a architectural decoupling. That means you need to have a separate storage and also the separate compute as well. Take a system, for example, your Snowflake is there. That also has a separate storage and separate compute. What is the advantage with those kind of an architecture decoupling? If you are doing the more processing, you can add more number of the compute and do this. And if you're dealing with the more storage required, just add more number of the storage. So that is the first thing you should able to scale independently with the storage and the processing layers. And the next key foundation is elastic scalability. As the data volumes is increasing, we should able to do a auto scaling as well. Should able to do auto scaling for your workloads and scale up, scale down based on your requirement, based on your data, based on the volume of the data, based on the workload demands. That is where the elastic scalability is the other foundation for your platforms. Then you have the fault tolerance. That means even after your node failed or your cluster failed or your master component failed, still your pipeline should be able to run as it is. That is what the fault tolerance and resilience means. And then comes to the data reliability and the integrity. That is where in the data integrity, you should not be having any of the duplication and no corruption and no data loss. And other thing is, even you after you implement all these things, if you don't have the other important foundation is observability, then that is a big challenge you will be seeing. That's why for any of the data platforms, observability is the other important things, especially for the scalable and reliable platforms. That is where you monitor what is failed, what metrics, what are the current metrics we have, what are the logs which we have. We can even detect it and we can even prevent it as well. So observability plays a important role as a other key foundation pillar. And the last one but not the least is a governance and the trust. That means any of the data platforms across horizontally, you should have your security in place and governance in place. That is where you should be able to see that who is accessing your data. And this particular pipeline, who can submit or who can view that or who can make modifications to that data? Or is there any PII data, PCI data in place? All these things you can identify through the governance and trust. So these are the key foundations for any of the data platforms. And how you can build your scalable platforms. If you see, the first and foremost step is in the discovery stage, you are going to understand your source systems. Am I getting my data from the batch pipelines or streaming pipelines? Or am I getting it from RDBMS systems? Or is it image files or audio files? or what format I'm getting. Is it a JSON or Parquet, Avro? You should be able to identify those data formats as well. Along with that, you also need to understand who are consuming these data. That means who are the downstream users for that particular data. Once you discover all these things in the stage one, then in the next stage called design, that is where you choose your right architectural patterns. That means, am I going with this medallion architecture? Or am I using any of the lakehouse architectures? Or if I'm dealing just with the streaming, for instance, can I go with the kappa architectures? There are different architectural patterns are available. You should be able to use those patterns based on your understanding about what type of the data you are discovering in the initial stage. And then when it comes to the scaling, that is where your horizontal scaling strategies are important. So in the RDBMS era, we used to have vertical scaling. That means we used to do scale up, scale down. That means in the same node, we used to add more number of the CPUs, more number of the cores. But horizontal scaling is not like that. You will be adding a whole number of the data nodes or whole number of the multiple nodes horizontally. So if my data is currently in the 1 petabyte, it increased to 10 petabytes. I can simply add more number of the nodes to support these use cases. And not only that, while you are building this, you also need to think about your partitioning strategies and sharding strategies as well. While you are fetching your data, it need not touch each and every of the partition, rather it can go to a specific partition and fetch. And other important stage is secure. That means you understand your sources, you have your architectural patterns, and you design your horizontal strategies and scaling strategies. And you must need to include your security in place, the governance in place, what tools I need to have. If I'm in Databricks, do I need to use a Unity catalog? Or if I am using an Atlas? Or there are a number of the tools you can use to implement this. IAM roles, security groups, RBAC policies. It is vast, but you should definitely include your securities also in place while you are building the scalable platforms. Not only that, when you look at your reliability in your platforms, that is where you define your reliability goals first. That means you should understand about, okay, I should not have any of the duplicates in my pipelines and there should not be no data loss. And it has to be recover faster even after any of the failures. So once you define your reliability goals, and then you can identify your failure points. The failure points would be, it can be failed at the ingestion, or it can be failed at the processing, or it can be failed at the consumption also. So then you need to design for your fault tolerance. That means I'm reading from API. So if it is failed because of some issues, what I need to do? Should be able to retry. And then, for example, if it is a Kafka and it failed in the middle when you are doing the processing, then you should be able to recover it by reading from checkpoint. Same with the replications. Even though one node goes down, the fault tolerance will be applicable through the replication. And then you need to protect your data integrity at the fourth stage. That is where you do the schema validations and quality checks, reconciliation checks, and all these things. Finally, as we talked about earlier also, you need to have your observability and alerting in place. That is where you're going to monitor your job health or any of the latency issues, any of the CPU issues, or is there any of the data freshness issues. And you can even trigger an alerts as well. You can send this alert to the pager duties, or you can send this alert to the Grafana dashboards. There are a number of the ways you can build your observability and the alerting. These are the things you need to remember while you are designing your reliability in the data platforms. And one important things, think about your anti-patterns. Make sure not to have any of the single point of failures. That is where we always emphasis on the high availability of the systems. And also Anti-pattern is no data quality checks, no data validations, then you never know from the source to the ingestions to the processing, you have the correct data, or is there any missing, or you will not be having idea about that. So make sure you have these quality checks, validation checks in place. And also make sure you have the observability in place with the logs, metrics, lineage, and other important things we tend to forget is schema evaluations. So when upstream changes, something like some new column get added or new data type get added, make sure all these details you are tracking it, and your pipeline should be supportive of this schema evaluation. And then one final thing which we need to remember is we should never ever think scalability and reliability as an afterthought. Before you implement your data platforms itself, at the design stage, much before itself, on the upfront, you should be able to think about these scalability and reliability. Then only we can build these particular pipelines which can be supportive of running any of your AI and ML or data analytics use cases. I hope this gives you at least a good understanding about what are the core areas. If you have any of the questions, this is my LinkedIn ID. Then you can just post me any of the questions if you have. And thank you very much for joining us. Have a great day.